Hello, everyone, and welcome to the latest edition of our Lightning interview series. It's been a while. We took a few breaks thanks to our ODSC Europe, which was in beginning of June, and our ODSC Europe, which was a few weeks later. So it's kind of a busy few months for us, but we're back with these, and we've got a fantastic guest. So super happy to be back. But do remember, we always want to make these sessions interesting and interactive. So please do introduce yourself, tell us where you're joining from, what you do, and of course, please feel free to add your voice and your questions to this conversation. So as you can see in your screens, our guest today is the highly regarded machine learning expert and author, Emily Weber, to discuss her recent book on pre-trained vision and large language models. But before we get into that, I want to say a few quick words about upcoming items we have here at ODSC and our AI Plus platform. So pretty busy month. We do have quite a few free webinars coming up over the next few weeks. We have one in July 18th next week, and on Paths to Insights that start with trusted data, and then we have another webinar on basically wrangling with raw data. And conferences we have coming up this summer include ODSC APAC. That's going to be virtual. So if you're in the APAC region, we have 2 days of, again, wonderful speakers and tutorials and workshops. And as you may know from probably more than one email, you'll see that ODSC West is back. Slight typo there. It's actually October 30th. to November 2nd. That'll be Monday to Thursday. So we're back for 4 days. We always kind of pride ourselves on being one of the top training conferences. I know it's very hard to get time away from work and life to keep up with this fire hose of innovation that keeps coming our way in AI. So if you have time, please check out ODSC West. It's in Burlingame, California, just south of San Francisco. Great spot. And if you can't join us in person, join us virtually. And yeah, definitely, as you well know, a lot of generative AI, large language models events happening. And come on, we can't be any exception, right? So we're super pleased to have come up with a very strong program at this point. I believe Ruby, who's running this for us, is already have our speakers, including today's speaker. Emily Weber is going to be doing a LLM tutorial for us. But I believe we've over 20 speakers participating in both sessions, tutorials, and panels. So again, fantastic lineup. I'm super excited what Ruby and the team have pulled together. And you can go out and check out some of the great sessions we've already lined up. And I believe she's releasing the time schedule on Monday. So again, that's a free event. If you have time, go check that out. And by the way, these interviews and all the other interviews, we've done some great interviews over the last 12 months. They're all available for free on our AI Plus training platform. We also have some good highlight videos from both ODSC Europe a few weeks ago and ODSC East about a month ago. So a lot of the sessions that were recorded there virtually are available on that platform. So you have a chance just check out aiplus.training. All right, so without further ado, we want to get on to our main event. So it is my great pleasure to introduce our guest for today, Emily Weber. So Emily is an author and principal machine learning specialist solution architect actually at Amazon Web Services, where she's made a significant impact, I believe, over the past 5 years. I remember Emily did a keynote, I think it was O'Reilly's last conference in London back in 2019, right before the pandemic. And she has a wealth of experience in guiding customers and others on their machine learning journey. And Emily's very well known for specializing in distributed training for large language and vision models, and is a renowned SageMaker expert. And for those of you who are not familiar with SageMaker, that's Amazon's very popular machine learning service. And as mentioned, she's very well known, especially in the AWS community. And if you haven't seen her, I think it's 15 or 16 videos on YouTube around SageMaker. I think that's well over 250,000 views at this point. Do check that out later today or when you have time. Otherwise, But as mentioned, she's also author of a new book that was just published on how to pre-train your vision and large language models in Python. So we're thrilled to have Emily join us today and share her invaluable insights and expertise in the field of machine learning and large language models. Emily, welcome to the show.
Hi, Seamus. Thank you so much for having me. And hi, viewers. Hi, chat. Again, feel free to say hello, introduce yourself. It's funny hearing about the exciting things that we've done in our careers, right? Obviously, everyone has these high points, and it always sounds really impressive when you bubble up just the top. And then, of course, what you don't see is all of the challenges, all of the struggles, all the times when we don't know what to do and we have to figure it out from scratch. And so, Seamus, thank you for the glowing introduction. And Chad, just don't feel intimidated. I too am a humble developer, and I too struggle with technology, as we all do. So thank you for joining the ride with me. We couldn't be here without you. So appreciate it.
Yeah, thank you so much, Emily, for joining us. And look, I think I've been following your work for quite a number of years, as I'm sure a lot of people have. And, being involved in ODSC has given me a great insight into, who are the influencers in the industry like yourself and what's going on in the industry. But I got to say, I think I was at ICML when they announced that attention is all you need paper. And I was like, that's pretty cool. But did I understand the impact it was going to have? No. And so when we reached out to you and you actually told me you just published a book, I think we reached out to you. I didn't even know you were just about to publish a book, because I think we were talking a couple of 3 or 4 months ago. So what I really want to know is you obviously, in the book publishing world, you have to come up with a book idea and all that stuff. And LLMs kind of broke late 2022, and then it was all over. But you came up with this idea of writing this book well before what everyone's calling now is the LLM boom. So really want to know, what gave you the insights into writing this book well before we got this hockey stick growth and interest in LLMs and generative AI? Because I think it was massively insightful.
Yeah, no, thank you. That's a great question. So there are definitely many answers. I mean, the deeper one is really, to me, the exciting moment was actually the scaling laws more than anything else. Yes, obviously, we care about interacting with LLMs and seeing really high performance, language coming out of models, but I was really moved by the scaling laws more than anything. In machine learning, so much of our work is experimental, right? We try one thing, we get accuracy, right. We evaluate the results, and then we try again. So it's incredibly iterative, it's experimental, but there's also this degree of uncertainty where there's just not really a good way of knowing how well your model will perform after a certain period. And so when I saw the scaling laws by Jared Kaplan back in, I want to say 2019, to me, that was actually the shift, because essentially the scaling laws give us ways to estimate the performance of your model. So it's literally an equation where you can say, oh, here's how many accelerators I have, here's how large my data set is, here's my model, what's my accuracy going to be? And then when you have that formula, that equation, you can then much more easily experiment and much more easily quantify how good your model is going to be. And so basically I saw that, and that pushed me to reevaluate my machine learning journey and the way I approached ML. And then again and again, that came up in a variety of ways as models got larger and optimization stacks got better. And then I spent obviously many years working with customers. So at AWS, working with customers who were doing their own large scale modeling projects way before it was cool, but because they saw benefits, right? They could also see this trend. And so that led me to believe that, yes, this really is the future.
Yeah, and I see, I think it was last week, Amazon announced a new $100 million initiative around large language models and Gen AI, which I would love to maybe get in a little later. But But the scaling laws, exactly. I definitely completely missed the boat on that. But what other things have kind of, because LLMs just didn't come out of nowhere in the last year or two, and they didn't necessarily originally at OpenAI, as we want to know. So what are the other things that have contributed to this moment in LLMs and large, both language and vision models? What are the advancements that contributed to the current capabilities we have now over the last few years, do you think, in addition to the scaling laws?
Yeah. So in some ways, I think if you look at some of the most interesting, the most state of the art, the most cutting edge performance in AI for more than the last decade, honestly, a lot of it has to do with scale. Like a lot of it at the end of the day comes down to building a really great distributed system, using techniques to optimize your data sets at really large scales, optimize your neural networks and your models at really large scales. Richard Sutton, who's obviously considered the father of reinforcement learning, he wrote this famous blog post in 2019, which he called the bitter lesson. Right. And so Richard Sutton's bitter lesson, which I discuss in great detail in the book, along with the scaling laws, essentially Sutton throws up his hands and he's like, oh, what we learn after the last 70 years of AI research is that what's ultimately most impactful is what uses the most compute. And so really, to me, more than anything, it's an efficiency gain. Like foundation models are powerful because they're just more efficient. Like instead of going after hundreds and thousands of these tiny little trees or logistic regressions or XGBoosts or RNNs or CNNs, like rather than, n number of models, like let's just create one massive model that does all the things, that has all the use cases, that has all of the high accuracy, and let's go really, really, let's front load it. Let's go big on creating this model, but then we can use it for everything. And so, yeah, with SageMaker and working with customers at Amazon, like it is a lot of work. It is tough to take a machine learning project all the way from ideation through to scaling, through to operationalizing, through to product lifecycle and management. Like it's a huge lift. And so foundation models are powerful because they're efficient. Like it's just a more efficient, more streamlined use of resources. And so once I saw that come to life, essentially through my work at AWS, I became convinced that this was just unambiguously the direction forward.
Excellent. And I'm sure there's more than a few experts on this session and who'll be listening in later. But to compare with us for a little while, for those of us who are newer to LLM and this whole phenomenon, because your book, which we talked about earlier, does an excellent job of explaining this. So over a couple of chapters, but maybe you can give us the condensed version. So can you kind of briefly explain the training process of large language models and how they learn from these vast amounts of data?
Yeah, definitely. So the way a large language model works, if you're new to this space, is you pick a data set, and your data set needs to be, if you're really pre-training an LLM, you're going to pick a data set that's at least a solid terabyte in size, maybe a couple terabytes. And that really you want to pick a data set that reflects a strong use case for your organization and for your teams. And I go into great detail on that in chapter 2 in the book. So chapter 2 in the book is all about picking the right data set, which is actually about picking the right use case, which is also about making a strong business case for your project. So all of that I outline in detail in the book and actually help you make a case in your organization for why pre-training is important. But I'm getting ahead of myself. So chapter 1 is just about pre-training. Chapter 1 is about foundation models, what they are, why they're useful, and how to create your own using this pre-training project, this pre-training process that is largely self-supervised. And so this is why, again, pre-training is valuable, is because you don't need massive data labeling. The process is self-supervised. So you can leverage data sets that are largely unlabeled during the pre-training process and use these either mass language modeling loss or causal language modeling loss to basically inject blanks into the text, and then the model learns how to predict the right text as it's going. And then, yeah, so the book walks you through all of the stages of this project, from learning about the very foundations of foundation models, actually, to choosing a right data set, to choosing your right model, to configuring your environment appropriately. The book, again, features AWS, so you'll learn about SageMaker, distributed training on SageMaker, model parallel and data parallel. You'll learn how to optimize your data sets by building data loaders using FSX for Lustre. You'll learn advanced techniques, so how to compile your model, how to evaluate throughput and optimize your network topology, actually using optimized backends. And then the book continues and looks at model evaluation. So you go back to stats and you learn how to think about classification, for both language and vision. I really tried to stay true to that. So every chapter has examples from both LLMs and vision foundation models. And then the last part of the book is about deploying your model. So learning how to optimize the size of your model using quantization and data representations, and then using distributed hosting on SageMaker, for example, and then wrapping that in a pipeline to operationalize it, and then get human feedback on the model to then fine tune it and optimize it further. So that's the full scope of the book, and it covers quite a bit.
Yeah, and such a comprehensive book that I just wrapped up reading myself a few days ago, and I think it's very accessible to beginners. And but I've found for someone who's starting to work on LLMs myself, some great nuggets of information there, and especially around the ML ops and LLM ops, as we're starting to call it now. And we'll dive into some of those topics, but just want to continue to start at the beginning here. So it's interesting when we talk about scaling laws, and Andrew Ning's blog last year about data-centric AI, and how the focus for the last decades has been on models and what we're now calling like small-scale machine learning. And it's interesting what you're saying along similar lines, but in your book, you really emphasize the importance of data set preparation. So I can see where these things are aligning, data-centric AI and data set preparation, because yeah, so if you can walk us through like the importance of data set preparation to the success of pre-trained large language models, because when I talk to some folks on my team and other people about it, it's like, let's just scrape web data from everywhere. Let's just pull all the data we have in our database, put it in a bunch of documents, upload it, because we've all seen those kind of those videos on how to do that. And hey, we got a large language model with a bit of fine tuning, which I think is hopeful will be a word I put on it.
Yep. Yeah. No.
Optimistic.
Yeah, no, it's funny. I mean, I feel like in some ways all of the interesting work right now is really around data set creation, because the core technology that really everyone is doing, right, to create your own generative pre-trained transformer, however you want to slice and dice it, your own LLM. Right now, everyone's pretty much using the same loss functions, right? We're all doing causal language modeling loss. Everyone is using transformers at different sizes. So there's not a huge amount of innovation there. However, the performance of language models is shown to vary dramatically based on the data sets that are being used. And I think this is especially interesting in sort of niche areas where there isn't already an LLM that performs well. So for example, obviously, Wikipedia knows general things, right? Reddit knows random things. There's a lot of content that's online. But when you compare that with the knowledge and the expertise and then the data sets that exist in different firms and different companies and different personalities and personal expertise, there's actually a huge amount of difference between general information online versus domain-specific information for a different industry or a vertical or a take on life, actually, a take on reality. And so I love looking at projects that explore these different data sets. because that seems to be the best way to get, true performance out of your LLM is by, finding and then enhancing a data set that is different, a data set that's unique, that has, what is differentiated about your company and about your organization, and includes that in the LLM. Rather than just using, LLMs that are trained on the internet, because that doesn't necessarily translate. And this is especially true with even just vocabulary. So many really complex terms in finance, in legal, in healthcare, in media and entertainment. The terminology itself doesn't map one-to-one. And so Bloomberg, for example, created the Bloomberg GPT model. And that to me is a wonderful example of creating an LLM that is expert in a given domain. So they constructed a data set that used half open source online data sets, such as are in Common Crawls, and then half of their data sets is from their own sort of proprietary Bloomberg specific content. And then we're able to create a model that performs extremely well in the financial domain. So I think that's a promising trend.
Yeah, we actually have one of the contributors to that project joining us for our generative AI event on July 20th. So that's going to be interesting. And it is so interesting because I've already seen it played around with various LLM tool offerings around training, education, healthcare, and yeah, they're black boxes, right? So we really don't know how these were trained, and we've always seen these lawsuits now on some of this on the legal aspect of legal advice.
Yeah.
So we could talk a lot about that, but yeah, it just goes back to show you to your points. Data set preparation again is so important here, and again, I think your book covers that so well. But then you quickly moved on to, I found it that your approach to pre-training and fine-tuning large language model in chapter 3 of your book was quite enlightening, particularly your insights on model preparation and base models. So yeah, so I'd love you can explain to our audience.
Yeah.
Small scale base
Yeah.
models.
So I think a lot of people don't realize how large the spectrum is in model sizes. When we think about an LLM, a lot of people default to thinking, oh, you mean, hundreds of billions of parameters, when in reality, you can pick really any model size, starting from very, very small to something that fits on a single accelerator, that runs really quickly, that is just generally smaller. And then essentially the spectrum goes from there all the way up to the massive one. And so chapter 3 is really about finding your best base model. And so it encourages you to learn about a variety of foundation models that are available for pre-training, and then helps you, use the scaling laws actually based on the data sets that you have, based on the compute that you're interested in, and increasingly based on the inference runtime that you can accept, and uses those criteria to then narrow it down to a set of model families and a model size. But then even once you have your model size, this is also, I think, maybe not as well understood, that when you're like working on a distributed training project and when you're serious about wanting to become good at distributed training and you really want to master that as a core skill, you can start with an absolute tiny model and get something really good really quickly. Like it's actually better to start with a small model and do experimentation in a very simple way and then scale up. So actually in the book I suggest 4 phases where I say, you can actually, I suggest taking a phased approach to the model development process, where you're starting from something that's really, really small, that fits on, a one accelerator that uses a tiny data set. and then run experiments to prove that your pre-training process is going to work, like validate that, yes, indeed, this is worth your time and worth the resources. And then I show you how to take incremental steps up from there to continue building the case and continue getting really good performance out of your pre-training projects.
No, I that was actually one of the most valuable insights in the book for me, because as we're working with some of our own LLM models here, that was very sage advice, if you excuse the pun. So we do have a question here from Cruz. Can you please explain the difference between model parallel versus data parallel, which I know you covered in your book in various points?
Yes, very happy to. So data parallel is really the first one that you want to understand. Data parallel basically means you have a large data set and you are going to make copies of your model. So say you have an instance, say you've got a box with 8 accelerators, and your model can fit in one of those accelerators. Using data parallelism is going to give you 8 copies of that model, actually. So you have 8 copies of the model. It's the same model, but they're seeing different slices of your data. So the data parallel software framework will point to your data that's coming in. It'll point to your mini batches that you define in your training loop. And it will split those out. It will send those to all of the 8 accelerators. All of them will run the forward pass on their model. They'll compute the delta, and then they'll take the average of this and then back propagate that into the model. And because, and I say this in the book too, because of our friend, the commutative property, for those of us who love to think about mathematical properties, so the commutative property, it is exactly the same as doing a one GPU. So if you're using only one accelerator, because the backprop algorithm is a weighted average of all of the records in your data set, it's mathematically the same if you do it on one accelerator as if you do it on all 8. So what that means is data parallelism just lets you run faster. It's like horizontal scaling. If you have a job, if you have a model that takes days or weeks, sometimes even months to train, odds are you can use data parallelism just to make the thing go faster. It's like horizontal scaling. You throw more accelerators at it, you throw more instances at it, and then the data parallel framework, if it's a good one, will sort of swallow all of those, and it'll build this world that's knowledgeable about all of those accelerators, and it'll continue making more and more and more copies of your model, but still giving you that single one back that's the average of all of them. So data parallelism, if you're new to distributed training, data parallelism is the first topic to really learn and to really understand and to get comfortable with it. Once you're comfortable with data parallelism, then you can move into model parallel. And so just to answer a question, so model parallel is solving for the case where your neural network itself is so large that the neural net can't even fit on a single accelerator. It's just literally too big. Like your accelerator has tens of GBs of memory, and your neural network, maybe it takes 100 GBs of memory. So it just literally doesn't fit on your accelerator. And so model parallel is a way of splitting the model. So model parallel is going to break the neural network into pieces, and it's going to put pieces of the neural network on all of your accelerators. So back to our box of 8, if you have 8 accelerators, you might have 8 layers in your neural network, for example. So maybe one layer on your neural network is taking up a full accelerator, a full GPU. And so model parallelism is really about just strictly working with large models and sharding them across accelerators in a variety of ways. Now, just to bring it all home, when you are pre-training an LLM, odds are you're going to need to combine both of those. And that is because your data set is just too large. Like you have multiple terabytes of tokens that you need to work your way through. And so it's just infeasible to only have 8 accelerators running on that thing, right? It'll just take way too long. And so there are techniques to combine model parallel and data parallel, and that's how you actually use your clusters. So if you really do have a cluster with tens or thousands of accelerators out there, what you're going to do is you're going to combine model parallelism with data parallelism. And so that's called basically 3D. Those are those 3 degrees of parallelism, including the optimizer and a number of other techniques. Now, if you feel like that's really hard and really challenging, and if you feel like that's intimidating, take heart, because again, everyone starts this process by not knowing how it works. The only way to learn how it works is to start by not knowing and then working your way up to knowing. What I'm excited about at AWS in particular is that I believe we have made this process incredibly easy, actually. So again, because we've been focused on customers and developing managed capabilities, especially through SageMaker and distributed training in SageMaker, it is now much more accessible than it used to be to the average Python developer. So today, the average Python developer, as I show in my book, you can point to one of our example notebooks, and you can be pre-training your own 30 billion parameter GPT-2 based model with like a day of poking. Basically, you can just run this notebook start to finish, and it's going to work out.
No, great. And I think it was in your chapter around hyperparameter tuning. I think you gave some great examples of on tuning a scale-up example. So using, 1 or 2 instances with different sets of GPUs, and then looking at the world size, and then the batch size and the learning rate. So since we're going there, why don't we talk about take a moment to talk about the hyperparameters and their impact and performance. We haven't talked too much about vision, but maybe on vision and language models, because finding the right parameters, it seems to be sometimes more of an art than a science. If you can delve into that a little, Emily.
Yeah, certainly. So hyperparameters, choosing the right hyperparameters. I mean, certainly the first thing that everyone does is just follow the paper. So if you're day 1 on this, then certainly go find a project that inspires you. Find a model you like, find a data set, find an example that closely approximates what you need, and just use those hyperparameters to begin with. That's always the first pass. Once you've exhausted that, there are 2 things you want to keep on top of. One of them is actually how large your cluster is and how many accelerators you're working with. Something that I try to make understandable in the book is learning how to actually change your batch size and your learning rate as a function of your overall cluster size. So every time you scale up the number of nodes in your machine, in your cluster, you want to actually update your batch size, and you want to update your learning rates
Right.
to more easily, or to be knowledgeable about that in order to give you better performance. So that is part of it, just sort of updating your batch size and your global batch size and updating your learning rate accordingly. So that's the second one. And then the third one, to me, is more sort of a future trend, which is actually hyperparameter tuning. This is especially common in some of the earlier phases of a pre-training project. So when you are working on your 1% sample of the data, or you're working on the absolute base version of the model, you can do hyperparameter tuning, can and should run some actual hyperparameter tuning to test all the different versions of the model and see if you can find better settings for the number of heads, maybe, or for different ways that the model learns, different techniques, different settings for that specific foundation model you're interested in. And then, yeah, you might find something awesome. So there's definitely room for hyperparameter tuning, I would say, in that early phase at a smaller sample of the data, but then also for fine tuning. So one of the fine tuning techniques we cover is parameter efficient fine-tuning, and then certainly reinforcement learning with human feedback. And especially for PEFT, for parameter efficient fine-tuning, hyperparameter tuning seems like a great match there. So I think we'll see more and more models that are fine-tuned using parameter efficient fine-tuning and combining that with hyperparameter tuning, because then you can really max out performance in an astonishing way.
No, great insight, Emily. I think we had a question here from Krishnan. Great question. A question I started asking as well, and I just want to read it out because sometimes we turn these into podcasts. But are there any feasible or low-cost platforms to experiment on model parallelism and data parallelism?
Yeah, so Krishna, definitely there are. One option is called SageMaker Studio Lab. So this is a free Jupyter-based environment that you can log into without a credit card, just using your email address. And then that gives you a GPU, actually. So there's a CPU and a GPU option for Studio Lab. And then really to experiment with model parallel and data parallel, you really just need one accelerator and maybe two accelerators. So once you have two accelerators, then you can start to go deeper and deeper and learn about how to take your model, how to copy your model onto the two accelerators, and then maybe how to distribute your model onto the two accelerators. So you really just need something very small and very cost effective. Studio Lab is a great example. And I'm also really excited about the custom accelerators at AWS. So our Trainium instances, which are very cost effective. And these are a great way to learn about and explore distributed training, because it's very possible and very easy to run your model across the different accelerators in a cost-effective manner. So I would say, again, start with Studio Lab, and then after that, look at instances that are just less expensive and shoot for something older, like go for the oldest GPU you can, the oldest instance. My go-to for development is it's the G4 .12XL. So it's this instance that we have on AWS that's 4 GPUs, but they're somewhat older GPUs, so they're less expensive, which means the availability is really nice, and the experience of working with them is great. And so I explain this in the book as well, that you can do a lot of really powerful development and test on smaller GPUs, on less expensive GPUs, and then save Big Bertha for the run, and then go, for the win when you're doing the large run. But outside of that, stick to less expensive ones.
And maybe a little insider trick is I noticed that Amazon is very generous with credits to startups. So, Krishna, maybe you might want to jump on the large language model startup wagon. It's crowded, but there's always room for more.
Hey, large vision models, though, maybe underappreciated.
Yeah, oh, for sure. And they've been very entertaining over the last 12 months as well. Yeah, so just plunging in here to a bit of what we're calling now large language model ops. But I did like your section where you looked at the challenge of model evaluation, right? Because a lot of people are talking about that. So, even with small scale models, the challenges of evaluating small scale models have been widely recognized. People kind of view these a bit of a black box, and there are definitely various techniques and open source tools for doing this. So I'm curious to know if the techniques commonly used for small scale models can be applied to large scale models as well, or need new evaluation techniques specifically tailored to LLMs and large vision models.
Yeah, so for evaluation techniques, I do think we need new evaluation methods for language in particular. And I go into detail in the book as well. So before I was in computer science, I was a creative writer. Actually, I wrote a number of plays when I was in college and wrote short stories.
You got out of that business just in time. Sorry.
No, I
You
love.
have a crystal ball somehow. I don't know. I need access. Sorry.
Man,
I couldn't help myself
just
interrupting there.
just follow my gut. But
Yeah.
yeah, so so I love creative writing. And if you've sat in a literature class or a reading and writing class, um, what you quickly come to find out is that many people interpret the same text very differently. This is just core to human nature. Different people read the same story and they respond to it completely differently. Like person A sees one theme, person B sees a different theme. This is in large part what the humanities do. The humanities exists to discuss this and help people learn how to enrich their thinking about creative text like that. And so this is interesting because generative AI, generative language, generative vision kind of poses this very different question to the ML community, right? Because we're so used to doing classification or regression or object detection where it's very easy for the math to be right. Like it's very straightforward, it's very obvious, it's very objective. But it's significantly harder evaluation techniques and evaluation methods for language because people read things different way. Our guts respond to them differently. And so that's one way that reinforcement learning with human feedback, I think, is so exciting, is because it aggregates that subjective human response at scale. So in an RLHF world, what we're doing is we're collecting feedback from tons of humans, but not just like, oh, positive or negative, or yes, no, but sort of this ranked human preference. So, like, humans on average tend to like this and they tend to not like that. And so, when you turn a model, when you take that aggregated human feedback and create a model on top of that, a reward model, and then put that into a much more creative reinforcement learning agent. And we can talk about that in a second. But when you combine that with reinforcement learning, it produces generated text that humans just like more. And so I think the evaluation in LLMs is probably the most interesting project because it forces us to grapple with subjective human responses, with personalities, with tone, in addition to, of course, accuracy and robustness and mitigating bias and many other sort of more classic ML evaluation techniques. So certainly evaluating language models is a full-time job and is very, very fun.
Yeah, that's great. So there's a quote in your book that I found was quite hilarious. I forget who said it. Was I forget who you attribute to as AI is incredibly smart and also shockingly stupid, which
That is
I definitely
usually.
subscribe to that school of thought. Very intelligent, but also shockingly stupid. Sorry, who was that?
Yeah, so her name is Yijin Choi, and she's a
Oh yeah,
professor at the University of Washington and the A2I group.
yeah. So, and speaking of going on that trend, you did do a great job on covering bias and fairness within large language models, which there's been a lot of ink spilled over this topic. So I guess a two-part question, like how can we make sure that we're building fair and unbiased large language and large vision models? And also the second part is that's a well-known challenge we have, but what other challenges are you seeing in your work around large language and vision models and generative AI in general? So,
Yeah, sure.
that's a long question.
So I think to attack the bias question, I would say there are three sort of levels that you can use to go after bias in your LLMs. And by the way, you should heavily expect that your models will be biased. Heavily expect that your data sets are biased. And this is because Because we don't live in a perfect world, right? Like we live in a heavily skewed world where human beings aren't already evenly set into all of these nice natural groups. And so our models, of course, learn that. And then when we don't take steps to mitigate that, what happens is that the models then perpetuate bias systems. And so I say this because sometimes people in ML, like they know, yeah, it's a problem, but they don't really understand because they think like, oh, my model's more accurate. Isn't that better? And so the reason why we care about bias in your models and specifically identifying it, mitigating and monitoring it, is so that they don't continue to perpetuate a bias system. So with that being said, there are 3 ways to go about this. The first one is at the prompt level. So when you're working with the prompt for your language model or for your vision model, you can just be more explicit in the prompt. You can tell the prompt, I am looking for this type of person in this type of activity with this type of background. And when you're much more explicit, then it's easier for the model to produce a more diverse array of outputs. If you leave it to the model to decide, then yes, it will choose the most stereotypical thing without a doubt. So at the level of the prompt, you can be more explicit. And then at the data set level, you can also just go get more samples, like look and think about the array of people that you have, the array of groups that you have, all the different segments and the intersections of those individuals in their different parts of life. And then, do some sampling. So remove some samples and go get more data just to make the data itself more robust. In language, a common way of doing this is just, it's called counterfactual data augmentation. And it's basically pronoun switching. So in your language, every time you've got a pronoun of A, switch it out to a pronoun of B, and then rinse and repeat. So there's certainly at the data level. And then finally, at the model level, there's work to be done for what's called a fair loss function. So you can write a loss function to reflect your values, actually, and to reflect the sort of goals that you have around a variety of projects and groups and values. And then you can actually literally put that into the loss function and do hyperparameter tuning. So then you can do essentially fair tuning for your models to improve their performance in different categories.
Yeah, and unfortunately, we don't have time to cover it here today because we're kind of running out of time. But your book did have a very thorough chapter on prompt engineering around zero-shot learning and few-shot learning and chain of reasoning and all these very interesting techniques. Because I do want to ask a question. I had the pleasure of going to Northeastern University down the road here in Boston about a month ago. Jan Lacuna was speaking there. And of course, the subject of this talk was, you guessed it, large language models. So yeah, I'm sure if you follow Jan Lacuna on Twitter, or maybe he's gone over to Meta now, but anyway, he should be on MetaThread, right? MetaThread just launched, so he's going to be torn. Do I go on Threads or I stay on Twitter? It's going to be interesting where the loyalties lie, Musk or Meta. But anyway, his talk was very interesting, and nothing you probably haven't heard on Twitter, but essentially, he does acknowledge the success of large language models, but he's got a kind of a what I call a Gary Marcus view on it. That's at the end of the day, it's going to be a bit of a dead end, which I'm not sure if I subscribe to that too, because I do believe in what you're talking about in scaling along. So, but it's interesting, even though we're at the very cusp and at the beginning of these large language models explosion or boom, people are already thinking about what comes next. So given your insight and being one of the top experts in the field, what do you think the future directions and possibilities for large language models and large vision models hold? And where is this going in terms of technical capabilities?
Yeah, certainly. So I think that reward modeling is really a critical area. And I say that because reward modeling is extremely challenging. It's very, very hard. It's not for the faint of heart. And there aren't a lot of there are a couple projects that are open source, but there's not like a really, really robust reward modeling technical solution that everyone is out using. So I think reward modeling is sort of a near term goal that we as the industry should be creative about, and have a really nice way of just doing reward modeling. Um, Certainly data labeling, data set creation. But I think too. So I obviously I love Jan LeCun. I think he's a wonderful, and I feature him in my book. I sort of talk about his MNIST story as an example of how you can be interested in something that's much further, much earlier than others. But yeah, I think there are two very different trends, right? One trend is academic interest in creating extremely intelligent artificial intelligence, right? And so you have this goal for more and more and more intelligent AIs, and that goal is one direction, right? And then separately, you have these business goals, which is, hey, let's optimize for the customer experience here, and let's use our data sets, and let's create great products. And so I see those two goals as overlapping, but as distinct. So to me, when like Jan LeCun and others are rattling the cages for like dog level intelligence, and why we're still not yet at dog level intelligence, like I say, yes, that's a great goal in an academic setting. But then in business or a product setting, like the goals are just different. Like I don't need dog level intelligence. I need a great customer experience. And so I'm really interested in certainly customer centric research and customer centric products that develop things that people want and that people use. And like, yes, everyone wants, smart technology that's easier, that's faster, that's more efficient. But I don't know if we all need digital dogs. Right? Like there's a difference there. So that's my take on it.
Yeah, so great. So Emily, what's the best way for people to follow your work?
Yeah, sure. So certainly, I'm quite active on LinkedIn actually. So you can connect with me on LinkedIn. You can send me questions on LinkedIn. I will try and respond to you. I'll announce on LinkedIn when I'm doing different activities. And then I'm also on Twitch actually. So I'm on Twitch on Mondays, 9 a.m. Pacific. It's an AW show. It's called Build on Generative AI, and so every week we do screen shares and have guest speakers and take a look at demos and things. And so we're taking off July actually, but we'll come back on in August and do some fun stuff there. So that's a great place as well. Oh, and then also go talk to your AWS people. So your AWS account managers, solution architects, technical account managers. All of them are like 2 hops from me. So go talk to them. And then have a chat about what you're interested in, and I can literally come talk to you at work through your AWS people.
Yeah, great. So I apologize to everyone who we didn't get to answer all the questions, because a lot more questions than usual for sure, and a little longer interview than usual for sure, but very well spent time. Emily, thank you so much. Thank you for being so insightful. So remember, if you want to learn more about fine tuning and every other aspect of large language models, do check out Emily's book. It is a fantastic read. Again, I found it very insightful. I'm not getting paid to promote a book or anything like that, believe me. And Emily will be joining us on July 20th at our Generative AI Summit. So we should have kind of renamed that LLM Summit, but LLMs was just coming into the nomenclature then. So do check out our July 20th event if you're interested in this topic. We had a ton of fantastic speakers just like Emily, and yeah, we'll be back. We may or may not be taking off July, but Emily, you're taking a very well-deserved break, I know for sure. So thank you so much once again for joining us, and looking forward to chatting again on July 20th.
Likewise.
So thank you, everybody.
Thank you, Seamus. See you soon.
Yes, see you soon. Bye for now.
Yep. Bye.